Okay, in this podcast we're going to talk about mole conversions between volume and moles. In this case, it only applies to gases because of the unique relationship between the volume and moles of a gas. Alright, if we talk about gases and volume, we need to talk about conditions because it turns out that volume of a gas can change based on the temperature and pressure involved. So we often talk about STP, which is standard temperature and pressure. So let's take a look at what that means. So here we have a gas, it's in a chamber, and the gas particles are moving around. And right now we have temperature controlled, so the volume stays the same. But if we were to, let's say, add some, let's keep pressure the same, let's add some temperature, let's make it hotter. If we do that, the volume is going to expand, right? If the volume is allowed to, it will expand. So when we talk about comparing volume and number of particles, we want to make sure we're doing it with where we have set temperature and pressure to be constants. So let's go back to the PowerPoint. So what we can say then is, let's talk about what STP units are first of all. So STP refers to both standard temperature and standard pressure. Standard temperature is going to be 0 degrees Celsius. That's generally what we'll use. It's the same as 32 degrees Fahrenheit, and it's also the same as 273 Kelvin, and we'll talk about that a little bit more when we talk about gases. Standard pressure, lots of different units for pressure. All of these are standard pressure, 14.5 psi, pounds per square inch. That's what we'd use in the United States. If we're measuring on a barometer, we'd say there's 760 millimeters of mercury. But the unit that we use most often in chemistry is ATM, or atmospheres. Standard pressure is, we say, is 1 atmosphere in 0 degrees Celsius. So under those conditions, so we always say at STP, at standard temperature and pressure, the volume of a mole of gas, volume of 1 mole of any gas, this is what's kind of cool, of any gas, is 22.4 liters. It doesn't matter whether I'm talking about something tiny like hydrogen or something much larger like carbon dioxide. Those particles of a gas, as you remember, are pretty far apart, like about 10 particle spaces apart. And because they're so far apart, it turns out that any gas in a container will have the same number of particles. If temperature and pressure are the same number of particles would take up the same amount of space. Pretty cool. So we can use this. If we know the volume, we can figure out how many moles we have, or vice versa. So let's do an example. So how many moles, that's our to find, are there in 5.0 liters of hydrogen gas? So one of the things you might notice here is hydrogen is written as H2. There are some elements that only exist as diatomics, which means that they don't exist as a single element, but they exist as two elements. And hydrogen is one of those. Some others are oxygen and nitrogen and chlorine. There's 7 of them, and we'll talk more about them and how to find them on the periodic table. But hydrogen gas is H2. So the question is, how many moles are given as 5.0 liters of hydrogen gas? So we're going to start with our given, 5.0 liters of hydrogen gas. And what we want to do then is convert it to moles, and what we know is liters of any gas is 22.4 liters per 1 mole of hydrogen. So my liters of hydrogen will cancel out. I'm left with 5 times 1 divided by 22.4, and that is going to give 0.22 moles. And we want the same number of sig figs as we have here, 0.22 moles of hydrogen. Okay, let's try going the other way. So in this problem we want to know how many liters are in 127 moles of carbon dioxide gas. Okay, so our given is 127 moles of CO2, and what we know is 1 mole of CO2 gas, or any gas, is going to be 22.4 liters of that gas. I cancel out my moles of CO2, and I'm left with 127 times 22.4, and when I do that, I want 3 sig figs, because that's what I have in my given, right? I'm going to end up with 2840 liters of carbon dioxide. Okay, So periodic table in this case doesn't help us. We're not using mass, so we don't need anything on the periodic table. All right, one more question. At STP, which has the larger volume, 1 mole of CO2 or 1 mole of H2? And the answer is the volume is equal. Volume is equal, and that's because 1 mole of any gas at STP is going to occupy the same exact volume, and that would be 22.4 liters. That's going to do it.